doing the vertical line test, so it does not exist at 1 because the function...
If the function doesn't exist at a point, it doesn't mean that the limit does not exist.
Okay.
It has nothing to do, the limit has nothing to do with the function being defined or existing at the point. Nothing. The function can be undefined but have a limit. Okay, so the vertical line test will not help. Is that okay? Okay, so
yes, thank you.
Okay. We'll have more examples. 3 from the right, from the left. Now we want 3 from the left, from the right, sorry. Limit as x approaches 3 from the right of h of x. What is it? 3 from the right.
1.
Very good. As x approaches 3 from the right, the function values get closer and closer to the height of 1. And now we're asked to find the limit of h of x as x approaches 3 from either side. I don't have to look at the graph. I have to look at the left, which is 1, and the right, which is 1, and I will conclude that the answer is 1. Very good. So look through and see if you want to work on any other type of problem before we look at infinite limits. So look through and let me know quickly before my tablet turns off by itself. It has a mind of its own.
Can you do 23?
Which one?
23.
23. Very good. Okay, I'm sure you're looking at the graph of 23. So, so we have the graph. It's right above here, but it's my tablet is asleep. Okay, got it. So here it is. The limit from either side of 0. So can anyone tell us the limit from either side of 0? That's 23.
3.
Very good. As x approaches 0 from either side, I look at the function, and the function values get closer and closer to the height of 3. Anything else? Do we want to work on any other problem, or we move on?
I have a general question.
Yes?
I feel like, I guess my confusion with this is just when I'm looking at x values and when I'm looking at y values. Is there like a way?
You have to look at both.
Better?
You have to look at both. So you are given the x values and you have to determine the y value.
Okay.
So you have to look at both. So when I'm asked the limit from the left, I get 2. And I'm asked the limit from the right of 3, I get 4. If I'm asked the limit from either side, I'll say it does not exist. It's not the same number.
Would it be helpful if, like, I made it a rule of thumb to always go along the x-axis first?
You have to, because otherwise you don't know where to look for the point. That's what I'm showing all the time. As x approaches 0 from the right, from either side, the function values are right here, closer and closer to 3. I have to look at x, and also I have to look at y to give the answer. I have to look at both.
So we're always given x. So the rule of thumb is to always look at the x.
I either have to start. If I don't have x, I will not know where to look. So if I ask you, determine a value of the function, you'll say, where? For what x? If I give you x, then you will be able to give me the y value. But if I say, just determine a value, you will say, but what? For what? For which x? So I have to be given x in order to determine the function values. Absolutely. Other questions? Very good question, actually. Anything else? Okay, so let's go to the next page now. The next page at the top, problems 41 through 50. Wake up, wake up, wake up. I'm not sure. As I said, it has a mind of its own. So let's look at problems 41 through 50. Ah, it's awake. It's awake, but when I get to the next page, who knows when. Okay, so let's start. I can copy the graph if this doesn't work. How do you wake up your tablet?
I kind of knock on it a little bit.
As I said, it has a mind of its own, but I can copy the graph. Okay, here it is. That's even easier. I don't need you, not you. I'm talking to the tablet now. So the graph in the book is not correct, 100%. It does not present the vertical asymptotes. Can anyone give us these two vertical asymptotes from the graph?
It would be 1, -3.
So x equals 1 and x equals -3. And you will not believe, but it's awake. Hey, thank you. It's probably the internet that does that. Okay, very good. I completely agree with indeed -3 and 1. So I'm going to copy the graph. So can anyone give us also, that part is hard to read, so I'm going to skip that, but I wanted to also determine the horizontal asymptote. It appears that it has two different horizontal asymptotes, so let's skip that. We don't need it. For what we are trying to do right now, we don't need that. But I really wanted to talk about that, but it's hard to read. Here's the graph. And here's the other graph, the other part. And it crosses at 3. Okay, perfect. So let's answer our questions. First question, limit of f of x as x approaches 2. I think it's 2 from the left. Is it 2 from the left? No, it's just 2 from either side. Okay. Can you say it again?
-1.
I agree. It appears to be this point, -1. So if I can zoom in, I can zoom in. I can zoom in. Not for long, I guess. So, as we see here, as x approaches 2 from either side, as x approaches 2 from either side, the function values get closer and closer to -1. Right here, this point. Next step. Next problem. Limit of f of x as x approaches -1. So limit of f of x as x approaches -1 from either side. Yes, I agree. -1 as x approaches -1 from either side. We see that the function values get closer and closer to the height of 1. So I agree. Anyone disagrees? Anyone needs help with that? Is that okay? Let me know. So then limit of f of x as x approaches 0 from either side. Can everyone sees the 2? As x approaches 0 from either side, the function values, where the function exists, function values approach 2 from either side. Do you agree with 2, everyone?
Yeah.
Okay. Next one, limit of f of x as x approaches -3. Limit of f of x as x approaches -3, and I think it's from either side. Okay. Oh, no, don't do that. Okay, -3 from either side. So let's take this one easy. We know we have a vertical asymptote at -3. And I'm asking now, as x approaches -3 from the left, what happened, or what do the function values do? What do they do? As x approaches -3 from the left, where will the function go?
Goes up.
Say it again.
Goes up.
When we say up, what do we mean?
To infinity.
Exactly. Very good. So we skip this for a second. We have to write that the limit of f of x as x approaches -3 from the left is infinity. Perfect. Now let's look at the other side. Here is -3. As x values approach -3 with larger values from the right, what does the function do?
Goes down to negative infinity.
Very good. Excellent. So then limit of f of x as x approaches -3 from the right is negative infinity. From here, what do we conclude about limit of f of x as x approaches -3 from either side?
It's dne.
Thank you very much. We cannot write anything. There is nothing there to write. Very good. Any questions on this? Limit of f of x as x approaches 1 from either side. Limit of f of x as x approaches 1 from either side. That's why I asked you, and you perfectly told me that this is another vertical asymptote. As x approaches 1 from the left, where do the function values go?
Positive infinity.
And thank you very much. When x approaches 1 from the right, where do the function values go?
Negative infinity.
For the same reason, but I have to write this on paper. Limit of f of x as x approaches 1 from the left, you told me infinity, and limit of f of x as x approaches 1 from the right, you told me negative infinity. Because of this, what will you say from the limit from either side of 1?
dne.
Thank you very much. So even if at the beginning this appears to be a little bit difficult, you will see you're going to get used to it. It's not a big deal. But at first it's new, of course. Limit of f of x as x approaches 3 from either side. Limit of f of x as x approaches 3 from either side. Anyone? Yes. So we read from this point. As x gets closer and closer to 3, function values get closer and closer. Closer and closer to 0. Closer and closer to 0. High to 0, low to 0. Okay, so this is 0 indeed. Moving on. Next one. Limit. Where are we? As x approaches -2 from either side. So -2 from either side. 0 indeed. Very good. Now you got the hang of it. Very good. Awesome. So limit, next one, f of x as x approaches -4 from either side. -4 from either side.
3.
Excellent. Well done. Good job. Limit of f of x as x approaches -infinity. Please don't do that to me. Please, please, please. Okay. So, as x approaches -infinity, as x approaches -infinity, x goes all the way, where will the function values go?
Negative infinity.
function values. We're talking about the height. A negative infinity will do like this. This is when it goes to negative infinity. But as, yes?
Would the function values go towards 2?
Exactly. Because this is a horizontal asymptote. As x approaches negative infinity, function values get closer and closer, closer and closer, closer and closer to 2. So this is 2. Y equals 2 horizontal asymptote at negative infinity. Okay, we have one more. Limit of f of x as x approaches infinity. Limit of f of x as x approaches infinity. So, as you see, on this side, the horizontal asymptote is y equals 2. But on this side, the horizontal asymptote is 1. As x approaches infinity, function values get closer and closer, closer and closer, closer and closer to 1. So then, the same thing, but y equals 1 at infinity is the horizontal asymptote. Any questions? Any questions? Are we feeling a little bit better?
Yes.
Perfect. So now I would like us to choose a problem. You choose. I would like to review graphing of a piecewise defined function and then answer a couple of questions about limits. So you can choose any problem you want from 61 through 68. And that's on page 104.
Can we do 67?
67. So I see 67 is a function h of x. And we have x plus 1. We have 2. And we have 3 minus x. And the first one is x less than 0. The next one is between 0 and 1. And the other one, last one, greater than or equal to 1. And we have to answer 2 questions. 0 from either side. And 1 from either side. So these are our questions, but first we're asked to graph. So I'm looking at the time just to make sure because I don't know I have, I think we can finish it in 8 minutes. Good. Okay, so as you remember when we graphed piece